As you recall, we worked last week on this applet where we were shown the height of a ball off the ground X seconds after it was dropped. So the red curve here shows that, for example, 5 seconds after the ball dropped, it was about 680 meters off the ground. So that means that it had dropped about 120 meters, which is the difference between 800 where it started and 680 where it was 5 seconds after. And so you can see that it's curved, which means that as the ball dropped, it was going faster and faster. Up here, you can see it really wasn't changing its vertical distance very much compared to down here where it was speeding up. It took 12.78 seconds for this to hit the ground. So basically what we're talking about are the x values between 0 and 12.78. And what we said was we have a function, and that function we called h of x. And here's the idea. H of x means that whatever value we plug in for x, the function tells us the height of the ball at that time. So, for example, we set x to 5. H of 5 is equal to 677.5. That means that at 5 seconds after being dropped, the ball was 677.5 meters off the ground. So we can plug in any value between 0 and 12.78, and we get a value that is equal to the height of the ball off the ground. H of 12.78, as we can see, is going to be equal to 0. And the reason for that is because that's when it hits the ground. We also know that when x is 0, h of 0 equals 800 because the ball, at the instant we let go of the ball, it's still at a height of 800 meters. So we have this function defined. The set of inputs is all the values from 0 to 12.78. That's called our domain for this function. The set of outputs is anywhere from 0 to 800 meters. That is the range for this function. And again, we call the function h, and the way we describe it is we say h of 0 equals 800. That means that when x is 0, y is 800, or h of 0 equals 800, because we show the value of the function on the y-axis. Those are the outputs on the y-axis, the inputs along the x-axis. Okay, so one of the other things that we can do here is we can add a second point. And so we can see that when, let's say, x is 6 and at a height of 623.6 meters off the ground, when x is 9, we're now 9 seconds after being dropped, and it's 403.1 meters off the ground. Well, I connect these two here. And when I look at the slope of negative 73.5, what that means is that for every extra second that the ball traveled or dropped, it went down in height by another 73.5 meters. So on average, between 6 and 9 seconds, the ball was traveling at negative 73.5 meters per second. If we set this to 8, then we see that the slope here is equal to negative 68.6. So that means that between 6 and 8 seconds, the ball was traveling at negative 68.6 meters per second, a little slower than what we saw before. And when we set this to be just 1 second after, the slope is now just negative 63.7 meters per second. And we can see that the line is a little flatter here than it was when we had this point down here where it was a little steeper. The flatter it is, the closer the slope is to 0, and the closer the velocity is to 0. Right now, when it's at 6 and 7, our slope is negative 63.7. And that's actually the difference between 623.6 and 559.9. Because what we're saying is that between the seconds of 6 and 7, the ball was dropping by a velocity of 63.7 meters per second. And so what we do is we take the total distance the ball has dropped, and we divide that by the number of seconds it took for the ball to drop. And so at 0 seconds, the ball is at 800 meters. At 10 seconds, it's at 310 meters. That means it dropped from 800 to 310 meters, or a total of 490 meters, 800 minus 310. The slope then is going to be that total distance that it dropped, 490, divided by how long it took for that to drop. So it dropped from 0 to 10 seconds, it dropped 490 meters. So the travel was negative 490 meters, which means that the average velocity was negative 490 over 10, or negative 49 meters per second. So that's the interpretation of the slope of this line segment connecting these 2 points here. Now, if we want to know how fast it's traveling, let's say at 6 seconds, well, we can try to get this as close as possible so that it's almost right on top of the red point, but it's a little bit distant. So between 6 and 6.1 seconds, the ball is traveling at negative 59.29 meters per second. Now, if we try to put the 2 points together, then we're dividing 0 by 0, and so we don't get anything. But right here, when the blue point and the red point are not right on top of each other, it will calculate the change in the height divided by the change in the time. And in this case, it gave us negative 59.29. And again, our interpretation of that is the ball traveled at a velocity of negative 59.29 meters per second.